Hello, we are Team 21. This is our project proposal video for CS454 course. Within our project, we decide to replicate and improve the selected paper. Our selected paper is automatically testing self-driving cars with search-based procedure content generation. We would replicate the work in a small scale and further find a way to improve techniques in the literature. From now on, I will explain about the outline of our project. First of all, this is the problem statement of our project. There are two ways to test autonomous driving software. One is to test in real traffic. However, this method is expensive and dangerous, so virtual test method is needed. This method is test method using computer simulation. This method is efficient and safe. However, it is difficult to make proper scenario for testing in exactly the load network for simulation. Therefore, the goal of this project is to automatically create test data to find problem with autonomous driving software. The target of this project is to generate the road map that efficiently tests lane keeping functionality of autonomous vehicle. In conclusion, the goal is to create a test case that is most likely to cause failure on lane keeping, which is map containing as many OB as possible. Here, OB means out of bound episode, which means the case that vehicle get out of the center of the road excessively. To solve the lane keeping problem, the proposed solution in the paper was S4, which is the system that evolved road network for testing lane keeping functionality of self-driving cars. S4 consists of two main parts: procedure content generation (PCG) and genetic algorithm (GA). PCG generated the virtual load automatically, and GA improves the test data by using crossover and mutation technique. First, PCG is automatic virtual load generation method. The virtual load consists of multiple load segments. First figure shows the example of load segment. PCG applies incremental approach. It generates whole load map from the load segment to load network. Second and third figures show the example of load map generation process. It randomly generates the load segment and make the load by connecting them. Also, load network is formed by combining generated loads. Second, GA is meta-heuristic method to improve the test data. As third, evaluate the fitness of load map by using this fitness function. The fitness value is considered by the maximum offset from the center of the load during the driving. This value is bounded to the half of the load width. Then, it improves the load map using three methods: mutation, join crossover, and merge crossover. Below three figures shows the examples of mutation and crossover method. To evaluate the actual algorithm introduced within the paper, the author used the driving simulator named BeamNG. This simulator is a accurate driving physics engine, and it provides intuitive API which enables programmatically configuring virtual roles. With this simulator, the author used BeamNG.ai as autonomous driving algorithm. It drives the ego cars along the center of lane by computing an ideal trajectory, and it behaves like conservative driver.
Now, let me introduce our project plan. Our project is basically focusing on implementation using Paper's algorithm. Within our work, we would propose our own evaluation tool and improve literature. In our project, we would propose new accessible evaluation method using MATLAB Simulink. In the paper, as I mentioned, they used BeamNG for simulation too, but it is not widely accessible and difficult to use. So we plan to propose new evaluation method using MATLAB. MATLAB is programming language which provides numerical computing environment which is widely used in researching area. Here, we would also design our own toolbox for new evaluation method. Also, we would improve the literature by proposing new mutation crossover methods. In the roadmap, the OBEs can be directly linked to geometric features. But in the paper, they used only single-point mutation and crossovers. If the OBE's existing point is cut in the process of crossover and mutation based on a single point, these features may be damaged. So, we thought that we can find new crossover and mutation methods that could maintain geometrical features from OBEs. Even more, we would improve poor parts in fitness function. The fitness function used in paper seems that there was something missing. For example, the car which gets out of the center excessively for a short moment may have more fitness than the one which repeatedly gets out of the center of the road a little bit. So, we would like to improve these parts and search for better fitness functions. As a further work, we also planning to add new factors to simulator. This is professor's feedback. There are two main points. One is it will be not easy to replicate, and second is BeamNG simulator will be hard to handle. For the first point, we thought we can replicate Paper's algorithm into our own implementation. First, there is expert library on GitHub, so we can reference it. Also, development can be divided into several parts, so project can be done efficiently. The biggest concern of our project is that BeamNG will be hard to handle. As I mentioned above, BeamNG is not widely accessible and has almost no examples. So we decided to utilize MATLAB Simulink for simulator, which is more open and widely used. MATLAB has nice accessibility, and it also provides automated driving toolbox. Moreover, it has many examples which can give us more extendability. Figure shows the result of running the driving scenario creation example using the automated driving toolbox provided by MATLAB. Thank you for listening.